Hey everybody, Mr. Richards here, and I'm going to be doing a read-through of the discussion directions for you today. Now, if you'd rather just read this on your own, that's totally fine. You don't have to listen to this. But if you'd like to kind of sit back and have it read to you so that you don't have to do as much reading on your own, you can just listen to me because I'm just going to be going through and reading what I've written here for the discussion. I'll also be adding some extra information or clarifying some things that would make it like too much if I wrote it all out. Now, if you listen to this and you still don't really understand what density is, you might want to do a Google search for something like density for kids. That might give you some videos, maybe some extra reading or some examples that might help you understand what density is a little bit better. Okay, so let's get started. So first of all, good morning everybody. Today, we are going to continue to learn about particles, like we have been doing with solids, liquids, and gases. The topic is going to be density, which is actually a really important thing for everyone to know about. Most people know that warm air rises and cool air sinks, but I bet they don't know why that happens. Most people also know that ice cubes float in most liquids, but if you ask them to explain it, they probably couldn't. Well, the answer is actually very simple: density. Density is basically a measure of how close particles are packed together in an object. In general, the closer the particles are, the higher the density. The further the particles are apart, the lower the density. And here's a picture. When the particles are spread out, like they are in a gas, it's less dense. If they get closer and closer, or super close and packed tight together, it's more dense. All right, pretty simple, straightforward. So let's think about those two examples that I pointed out above. The first one is warm air rises. Now, you may or may not have seen a hot air balloon, and that's something I'm going to talk about. But if you've ever been in a building that has multiple stories, like an upstairs and a downstairs, especially in the summer, you might notice that if you go to the downstairs, it's much cooler than the upstairs. Well, that's because warm air rises. All right, so hot air balloons. Now, if you've ever seen a picture of a hot air balloon, and here's a picture right here, you'll know that they can fly. Well, this isn't really true, as hot air balloons don't really fly, they float. But why? And how? Well, they aren't like regular balloon that you might have had at a birthday party or other celebration, one filled with a special gas called helium, which is also less dense than air. Instead, a hot air balloon has a big burner in it, and the balloon has a hole in the bottom. The pilot turns on the burner and the balloon fills up with hot air. Here's the most important part. When anything is heated, the particles are going to speed up and spread out. Now we know that from learning about solids, liquids, and gases. Well, if you keep adding heat to a gas, the particles spread out and become less dense. Now here's the most important thing. When something is less dense than what surrounds it, it will rise or float. In this case, the balloon is sealed on the top, so the hot air can't escape. Instead, it is captured, and as it rises, it takes the rest of the balloon and basket with it. Of course, because the air around the hot air balloon, outside of it, is not as warm as the hot air inside the balloon. Okay, next example. This one is ice floating in water. All right, we got a picture of an iceberg with a couple of people standing on it, and then just a regular glass with water and ice in it. Of course, you can see that the ice is at the top of the glass, not at the bottom. Okay, so ice floats in water, and that's really, really important for life on Earth. Both our north and south poles are covered in ice for the majority of the year, and underneath most of that is just the ocean. You also know that, when it gets cold during the winter and the lakes freeze, the ice is on top, so the fish and everything underneath the ice can stay alive until the spring. But anyway, but why does this happen? Didn't I just write about how when you heat things, the particles get further apart? Ice is cold. Well, something really special happens when water starts to get to the freezing point. The particles of water do get closer and closer until just before they freeze. When the water particles freeze, they actually move apart and form a crystal structure. The picture below shows how close water particles are when they are cold, warm, and frozen. Notice how frozen water, ice, has the particles the furthest apart. It's crazy. So here we've got cold water, particles close together, warm water, particles a little bit further apart, and ice, the particles are the furthest apart. What the heck? Now, ice is kind of an extra molecule. It's super extra. And what I mean about that is the particles, when they are forming in a solid, can't just be, super close together, packed tight, kind of like this picture in any sort of order. No, they have to be arranged in a very specific pattern. Okay? It's a regular and repeating pattern. And that pattern forces the molecules, or the particles, we could call them, of water further apart. Now, this is called a crystal structure. In 8th grade, you're going to learn about crystals and how the main idea of any crystal is that the particles are in a regular repeating pattern, but that's kind of a boring explanation. The coolest part about ice is that because these water particles have to be arranged in this pattern in order to be frozen, they have to be further apart, and therefore they have to be less dense than any water, which means that ice has to float in water. It's crazy. There's hardly any other particles, any other substance that does this. In fact, I can't think of any. You've got a piece of iron that's a solid, you put it in liquid iron, it's going to sink to the bottom. All right? And that's true for pretty much everything else on Earth. But ice is different because ice is extra. All right. So even with all the craziness of water, the answer to why does ice float in water is exactly the same as the reason why hot air balloons float in the sky. The particles are further apart and are less dense than the surrounding matter. Now, that's pretty much always going to be true. If you ever see something floating in or on top of something else, it's because it's less dense. All right? That's kind of a answer for everything. All right? Which is kind of cool. Not often in science or the world do we have one answer that kind of explains everything. So that's, that's cool, I think. Anyway, so here's what you actually need to do for today. So for the discussion today, I want you to answer the following question. A piece of wood is less dense than water. Will the wood float or sink in water, and why? Now, if you just listen to everything I just said, this should be a pretty obvious answer, and that's okay. Sometimes practicing and remembering things just means repeating something that is obvious and easy to understand. So, yeah, just write about why a piece of wood would float in water. Make sure you write it in a complete sentence, and you won't get full credit unless you put in that why. Now, if you want to earn a level 4, I want you to find an example of something floating somewhere else in your life. It could be ice in water or some other example. Take a picture of it, post it in the discussion, then explain why the one substance is floating in the other. If you do the level 4, you don't have to answer the level 3 question because, well, you're basically answering it for a different substance. So kind of the same thing. All right, that's all I have for you today. Remember, if you have any questions, you can always come to my office hours from 2:30 to 4 o'clock p.m. every day of the week at the Google Meets FAUSRICHARDS. You can also always email me. If I get an email from a student, I respond super quickly during the school day. Either one of those ways is going to help me get in contact with you and make sure that you understand and can do your assignment easily. All right, take care, everybody.